special day. All right. So, in a right triangle. So this part is review. There's some new stuff with triangles that we haven't learned, but today should be old stuff. So let's start with this. What are these sides called in a right triangle? Well, no, the named legs. They're around the right angle. They're 90 degrees to each other, perpendicular to each other. Okay, this side is called the hypotenuse. Hypotenuse should always be the longest side. Okay, so we did a worksheet on this like right before Christmas break, kind of as a fill-in reminder kind of thing. Let's say if this is angle A, usually use a capital letter. This side across from it is called side A, lowercase. Angle B, side B, angle C, side C. Okay, yeah, we're not doing Pythagorean theorem, but a squared plus b squared equals c squared. That's true. What we are doing is SOHCAHTOA. So, relative to angle A, what's this side all the way across the triangle from angle A? What do we call that side? No. Opposite. That's what I was going for. The side that's all the way across, like it's shooting out towards it, is called the opposite side. What's the side that's right next to A down here? Adjacent. Well, isn't this one adjacent also?
But it's hypotenuse.
It is adjacent, but we call this one the hypotenuse. So we got opposite, adjacent, hypotenuse. And then if we look at angle B, side B is opposite, side A is adjacent, and side C is hypotenuse. All right, ring a bell. Now with angle C, we don't really use, you can't really do trig with the 90-degree angle. You just use these other two angles to help you solve the triangle. So, SOHCAHTOA. Should have this memorized, if you don't already. What does the SO stand for?
Opposite over hypotenuse.
Sine of the angle equals the opposite side over the hypotenuse. Spits out a. You feed the sine function on your calculator some angle, like 40 degrees or whatever, and it should spit out a decimal, sometimes a fraction, but that tells you what the ratio of those two sides are, opposite and hypotenuse. So cosine is equal to AH, adjacent over hypotenuse. Tangent of the angle equal to opposite over adjacent. So make sure your calculators are in degrees. I don't think there's radians in this chapter. Radians, we always use radians with unit, like the rotation thing. This chapter is about triangles. Anyway, so you feed one of these functions an angle and it spits out the ratio. Okay, and you can use this to solve the missing parts of a triangle. Okay, let's just jump in. Unfortunately, they did not draw the picture for us. That would have been nice. But I'm going to kind of have to do it myself. You guys are going to choose. So on number 1, it just says triangle ABC. So we just draw a little right triangle called ABC. It says angle A is the 90, so B and C are just the other two. B is 25 degrees. We don't know C yet. Side A is 18. That would be the hypotenuse. I'm just filling in what they gave us. We're supposed to find B and C. Okay, so here's how it goes. You always start, because you got to feed an angle into these functions. So you start with an angle that you know. By the way, they didn't really ask us on this one, but they will later. How could I find angle C down here?
90 minus 1.
Right. these three angles have to add up to 180 in a triangle. 180 minus 90 is 90, minus another 25. So 90 minus 25 would give you that angle. They didn't really ask them. Okay, start with an angle that you know, and then a side that you're looking for, and a side that you know. You can only have one variable to solve these. So relative to 25 degrees, what is this side that we're looking for called? Opposite. And the side that we know already is called the hypotenuse. Which trig function deals with opposite and hypotenuse? Sine. So it should be sine of that angle that we're looking at equals the opposite over the hypotenuse. So sine of 25 degrees equals the opposite, which would be b, the unknown, over the hypotenuse, which is 18. Okay, sine of 25 is going to be somewhere decimal. It's what this ratio should be equal to. So you could plug that in the calculator. Let's see, where are we rounding it to? Just says 3 significant digits. You guys remember what 3 significant digits means?
No.
Just as a thousands.
No, that would be the thousandths place. So 3 significant digits could be like 76.1 or 2.35, like just three digits in the answer. So you just round to whatever the third digit is. Okay. So this is somebody plug this in the calculator so we get a visual here. Sine 25. Sine 25.
I got negative 0.13.
Negative 0.13 what?
2.
Okay, did you round it off correctly? Did you round correctly?
I got 0.4. Yeah, I got 0.4. I got 0.42.
Or okay, you need to change your calculator degrees. Same one sent me. Point for what? 2.26. Okay, that's fine. So how do we solve this for b if b divided by 18 equals that? Times 18. Okay, so times 18. And what does that come out to? Round to the third digit. 7.60, he says. Is that right? They got 6.1. Okay, so start again with looking for side C. Relative to this angle, side C is the what? Adjacent. So we have, looking for adjacent, we have the hypotenuse. Technically we could use the opposite, but since this answer is rounded off, it might not be as accurate as using the 18. So which function deals with adjacent and hypotenuse? Cosine. So this time it's cosine of the angle 25 degrees equals adjacent over hypotenuse. So it's pretty similar. We're going to take whatever cosine of 25 is times 18. And let's see, it should come out at 16.3. So you can plug in your calculator all at once. You can just do cosine 25. A lot of you might have to close the parentheses on that. If your calculator opens a parentheses and then hit times 18. Just depends on the calculator, I guess. Okay. What did I say that was? 16.3? See, it's not so bad. Triangle DEF, angle D is the 90 degrees. DEF. Okay, we're supposed to find, say E is 12, angle E is 12, and side E is 9. Find D and F. Okay, that's pretty much the same thing. Okay. I guess I'll go for D first. We'll go alphabetical order. Relative to this angle, D is the what side? And the side that we know already is the opposite. Which function has hypotenuse and opposite, or opposite and hypotenuse? Sine. So sine of the angle, 12 degrees, should equal opposite over hypotenuse. You guys might have forgot this. How do we do it when the D is in the denominator?
Sine of 12 divided by 9 divided by 7.
Yeah, that's true. So you don't have to like. Here's basically what happens. If you multiply both sides by D, that just kind of goes away over there. Then you have a D over here. And since D is multiplied to sine of 12, to get rid of the multiplied value, you divide by sine of 12. So it becomes 9 divided by sine of 12. So when the variable is in the denominator, what happens is the variable and the sine or cosine or whatever switches place. So as you multiply by D, it goes up. You divide by sine of 12, it goes down. Whoops. So it's 9 divided by sine of 12. Which should come out as 43.3. Okay, and then for F, relative to this angle, F is the adjacent. And still using 9, that is the opposite. So which trig function uses adjacent and opposite? Or opposite and adjacent? Tangent. TOA, opposite over adjacent. So tangent of the angle equals opposite over adjacent. Alright, so it's same situation. F, the variable's in the denominator. So you multiply by F, it goes up. You divide by tangent of 12, it goes down and takes its place. So F is equal to 9 divided by tangent of 12 degrees, which is 42.3. All right. Number 5. All right. Now it doesn't directly ask for this, but we will need side C on number 5. Does anybody know how we could find side C on number 5?
A squared. What's B squared?
Yes, Pythagorean theorem. So I said we weren't going to do Pythagorean theorem, but I was kind of wrong on this problem. So 12 squared plus 5 squared should equal C squared.
13.
Yeah, you guys remember that triangle? This comes out as 169 when you simplify all that. You square root that, you get C is 13. Okay, now A says find sine of A. Alright, sine of A, now we don't know what angle A is. There's a way we could find it, but we don't need to. But sine of angle A is supposed to equal opposite over hypotenuse. Okay, so what's opposite of angle A? 5. What's hypotenuse? 13. Alright, so B is cosine of angle A. So what's cosine supposed to tell us?
It's a cosine of B.
Oh, it's B. Whoops. Look carefully. Yeah, they keep jumping back and forth between A and B. Okay, cosine of B is supposed to tell us adjacent over hypotenuse. So what is adjacent to angle B? 5 and hypotenuse 15. So they're kind of trying to make a point right here. Sine and cosine, if you do are going to be the same if you use the other angle for one and the other. All right, C, tangent of A. Okay, tangent of A is supposed to equal opposite over adjacent. So what's opposite of angle A? 5. What's adjacent? 12. Okay, D says cotangent of B. So how would we find cotangent then? We haven't talked about that today.
You switch it over opposite.
Yeah, you flip it upside down. They're inverses, or sorry, reciprocals of each other. They're upside down. So tangent of B would be opposite over adjacent. If we're doing tangent, it would be 12 over 5. So cotangent is reciprocal of that, 5 over 12. Adjacent over opposite. E, secant. All right. I thought we knew this one better.
This is cosine.
Secant is cosine
Opposite.
upside down. So cosine of A would be adjacent 12 over hypotenuse 13. So secant is the reciprocal of that, and be 13 over 12. Cosecant is the reciprocal of sine. Sine of B would be opposite over hypotenuse, 12 over 13. So cosecant of B would be 13 over 12.
What do you do on 6?
Okay, well, they kind of want you to use number 5. So what do we know about sine of A and cosine of B?
They're the same.
They're always going to be equal. Yeah. They kind of want you to look at number 5 to figure the 6 out.
That's all we need to say is they're equal.
Well, that'd be 6A, yeah. Okay, 7, we haven't done this today. We've done it in the past. Actually, a lot last chapter, but not in triangles. Find the measures of the acute angles of a 3, 4, 5 right triangle. So 3, 4, 5 just means that's the sides of the triangle. So how do I find out one of these angles? You guys recall?
Inverse?
Yeah. So you can use any two sides, like you could use, since we know all 3 sides, you could use sine, cosine, or tangent. I'll just use sine, I guess. So sine of the angle. This time the variable is the angle. But sine of the angle is supposed to equal the opposite over the, I'll just point at a random angle here, we'll call this A. It's supposed to equal the opposite over the hypotenuse. So this is supposed to equal 4/5. So how do we go backwards to figure out what the angle must have been? Yeah, we do sine inverse of 4/5. 50.1? 53.1. Okay, we could do something similar to find the other angle, but what's the faster way to do this?
90 minus 53.
Right, 90 minus that acute angle should give us this acute angle. So we got 90 degrees down there.
36.1.
How'd you know the three, like it meant 3, 4, 5?
I just told us on the problem. It's at a 3, 4, 5 right triangle. The 5 would have to be the hypotenuse. You guys remember 3, 4, 5 makes a right triangle? Like this squared plus this squared equals that squared. But it just said on the problem that find the acute angles of a 3, 4, 5 right triangle. Okay, number 9. The legs of an isosceles right triangle are 1 unit long. Alright, you guys remember what isosceles means?
No. 2 equal sides.
2 equal sides. So they're saying the legs are both 1. So that's the 2 equal sides. Find the length of the hypotenuse in simplest radical form. If the 2 legs are 1 and 1, you guys know what kind of right triangle this would have to be?
45, 45.
It'd have to be a 45, 45, 90, yeah. Those have equal legs. And do you guys remember special triangles?
1 square root of 2.
Square root of 2. Yeah. So you could actually use Pythagorean theorem, 1 squared plus 1 squared equals c squared. Or you could use trig. You could do like sine of 45 equals 1 over x or whatever. But yeah, this is a special triangle. This is square root of 2. Would be the hypotenuse. Okay, B says find tangent of 45. Oh, B part 1.
Part A of part B.
Number 9, part B, question 1. Well, he was like crying.
What is this?
No crying, it's not close. All right, tangent of 45. So tangent is equal to opposite over hypotenuse. We can't leave square root of 2 in the bottom. You guys, a lot of your calculators do this automatically. You multiply top and bottom by square root of 2. Yeah, square root of 2 over 2. Question number 9, part B, question 2.
This is ridiculous.
Sine of 60. Wait, I'm on the wrong problem. Sine of 45. Number 10 is a 30, 60, 90. Do you guys remember the...
1, 3,
No.
1, 2, square root of 3.
Yeah. Okay, this would be the 60 and this would be the 30.
I got it.
Anyway, that's not number 9. Okay, number 9, part 2 was cosine of 45, was it? Sine of 45. Okay, sine of 45 is opposite over hypotenuse. Wait, I did number 1, part 1 wrong. I did opposite over hypotenuse on that one. Whoops. Okay, number 1 was supposed to be tangent, which is opposite over adjacent. Nobody's catching me on these. Opposite over adjacent, 1 over 1. So 1 is number 3.
Too busy thinking about how there's 3 parts to part B.
Cosine of 45 is adjacent over hypotenuse. Adjacent 1, hypotenuse, square root of 2. So it's the same thing as sine. So 1 over square root of 2 turns into square root of 2 over 2. C. Convert the answer in part B to decimal form. Compare these with the values. Actually, in your, you can skip C. And your guys' calculators are pretty nice, so they might actually spit out like square root of 2 over 2 instead of like the weird decimal. Unless you got a, you know, a little more basic calculator, they probably would spit out a decimal. But yeah, back when this book was written, all calculators would have spit out a decimal for this answer. But yours are nice enough, they usually on special triangles spit out the square root answer.
Part B on 10 has 4 parts.
Instead of 3, yeah. You can skip. So on 10 you can skip the C part.
Okay. Thank you.
We still doing 10.
Yeah.
On 10 has 4 questions on the B.
We still doing 13 now.
Yeah. It's easy peasy. Okay. An airplane is at an elevation of 35,000 feet when it begins to approach an airport. Its angle is degree descent is 6 degrees.
Doing 13?
My chance to draw my airplanes, which is legendary.
It's still better than Trey's.
Okay, so
Smiley face.
one of the kind of key things here is it says an angle of descent is 6 degrees. What do you guys think that means? And it shows me pictures. So if you straight ahead would be like 0 degrees. So going down from there, that's 6 degrees. Hey.
I added the other things on it.
Oh yeah. That's why it looks weird, right?
That's my airplane.
Yours looks like a fish.
Still drawing the line. This is
That's
a That was that.
Mine is bad. Alright. Let me flip.
Okay. So to the airport over here, we put like a little control tower down here.
What's going on?
This is an airport. Okay, it's 6 degrees down. All right. So if it's 6 degrees for the pilot to look down, like a guy on the ground, what angle would he have to look up? 6 degrees also. So if the angle of descent is 6 degrees, the angle of ascent, that's not the right word, but angle of elevation, that's what it is. The angle of the guy looking up would also be 6. So it kind of makes 2 right triangles. Like you could use this right triangle on top. Usually I use the one on the ground though. But they're identical triangles.
Let me see. I'm still working on it. It's a great airplane.
Okay. It says the airplane is 35,000 feet in the air. It begins its approach. What is the distance between the airport and the airport and the point on the ground directly below the airplane? So the airport and the point directly below the plane on the ground. So in other words, they're asking for the ground distance. That'd be X. The direct distance would be like the hypotenuse up here, right? Like the air travel, the distance through the air. The ground distance would be different. It would just be this horizontal line down here.
It's a tangent.
Okay, right. Relative to this angle, 6 degrees, what 2 sides are we dealing with here? This is the what side?
Opposite.
And we're looking for
Adjacent.
which trig function uses opposite and adjacent. So tangent of 6 degrees should equal opposite over adjacent.
This is not us. It's not him, Brad. You must not get all of them if you win.
Okay, the variable is in the denominator. Therefore, those two are gonna switch.
Oh, that's a big number.
Okay, well, remember the airplane's height is 35,000 feet.
Oh, yeah.
So, an airplane, you know, it's big distances. The airplane will be way out. What'd you get?
333,000.
And 2.
Okay, they just put 333,000. Okay, that's,
There's a B.
okay, what is the approximate distance between the plane and the airport?
Oh, now we're just looking for the other side. So is it?
Sorry, it says air distance. So that means like the direct distance up here. So that would be, let's call this y or something.
So is it A squared plus B squared?
Okay. Well, you could. Let's go ahead and use trig though to be more accurate. So relative to this angle, we have the opposite. We're looking for the hypotenuse. Which trig function is opposite hypotenuse sine? Shh, girls. So sine of the angle equals opposite over hypotenuse. So it's kind of the same thing. These two need to switch places. 35,000 divided by sine of 6.
There's a big number.
It says, what assumptions are we making?
That it's high up.
I'm not making any.
I don't know what they meant by that. They didn't answer their own question, so who knows?
I didn't do the problem.
Leah spent the past 5 minutes drawing an airplane.
Look at my airplane.
Time well spent, Leah.
It's a happy airplane. Can you go up on A so I can copy it?
It's right there.